Alright, so we've discussed iterated integrals, we've discussed double integrals, and now we've discussed criterion for their existence. Is there a relationship between the two? And so that's kind of where Fubini's theorem comes into play. So it says that if f is bounded on R, okay, that's a condition for integrability, and if we assume that the set of discontinuities of f has zero area. Okay, so that's the other condition for integrability. So the supposition here just guarantees that we have integrability. And then now here it says if every line parallel to the coordinate axes meets S, okay, and S again is that set of discontinuities, then and so if it meets, so if every line parallel to the coordinate axis meets S in at most finitely many places, then all the conclusion says is that the double integral is equal to the iterated integral, okay, in either order. C to D of, and then A to B, f of x and y, dx, dy. Okay? But so, what does this language about meets coordinate axes in finitely many places? Okay, so if we imagine, and this is kind of the diagram that we had in the last video, so we have our set S of discontinuities, and it's given by that line. What we think about is, okay, well, the coordinate axes are parallel to this line segment AB and DC. So if we take lines parallel to them, okay, well, so this line is parallel to DC, doesn't meet the set. This line is parallel to the coordinate axes and meets in exactly two places. Okay, so this is fine, and then so this would still give us that the double integral and the iterated integral would be the same, and we would continue and check all possible lines, and most of these appear to meet this example in at most two places. Conversely, if I check the other direction, okay, so that meets in two places as well, and so I have to check all the lines in both directions, meeting in two places. And so if I ever get a place where a line intersects in infinitely many places, so a line segment for instance, then I would not be able to say that the double integral is the same as the iterated integral. Okay, so that's the idea of Fubini's theorem. We will need to check this supposition as well as the integrability suppositions to be able to say that the iterated integral is the same as the double integral. Okay, and that's all for this. We have one final example, and then we'll be done with videos for this week.